All right, guys. So what we're looking at today is what we call the production possibilities curve. This is kind of the first graph that we'll learn here in macro. It's not a super complicated graph. All it really shows is kind of different ways for economies to uh, allocate their resources. The main thing between like capital goods and consumer goods. But it's a pretty important graph. It's kind of the first one we learn. It kind of gets used to graphing and shifting the curves and things like that. So, all right. So, what we're looking at is basically we've already talked about, kind of trade offs, opportunity cost, things like that. So, this graph kind of represents those trade offs, okay, and how countries, governments, economies, they have to, deal with those trade-offs, that idea of scarcity in order to produce both consumer goods and um, capital goods. So it just shows all the different ways that an economy can use the scarce resources that they have. Okay. So we have to assume four things, and these four things are not going to change. So if any of these do change, our graph no longer is accurate, and then we would have to, essentially draw a new graph or shift our curve, which is what we'll do kind of later on in this PowerPoint here. So four things we have to assume. Only two goods at each time. So like I said, it could be consumer goods, capital goods. It could just be like bikes and robots or something like that. Um, we also have to assume that full employment of resources are being used. So that means all the resources are being used efficiently, to the maximum of their ability. Everything's operating as it should. Okay. The other two are fixed resources and fixed technology. So, meaning, fixed resources, the number of workers, the quality of goods, the quality of the technology that we're using, all of those things all have to be fixed, kind of like frozen in time. They're not changing. If one of those things do change, then, like I was saying, we have a new graph, and that's when we'll get to where we shift the curve left and right a little bit later on in this presentation. So, first thing we're going to look at, this is kind of an example over here on the right of what the production possibilities curves look like. These numbers don't really mean anything. They're different for every example. These are the points along the curve. Okay, points inside, points outside. So this is kind of the curve itself. It's not really curved. It's kind of like, a quarter of a circle, basically. That's all it really is. So first thing we're going to look at is what we call the per unit opportunity cost. So we know opportunity cost is the sacrifice, what we have to, the alternative that we're giving up when we make a choice. Okay, so per unit, what is that opportunity cost? So here, this is a simple little formula. You just take opportunity cost, so the units sacrificed, you place it over the units gained, and then we have um, our per unit opportunity cost. So if we are looking at number one here is the example, we're going from point A to point B. Okay, so we're going at point A, we're making 14 bicycles to our 0 computers. This means we're putting every resource we have into making these bicycles. We're not making any computers because we can't put 100% into bicycles and 100% into computers. We only have our limited resources, those scarce resources. So we have to decide where to put those resources at. Okay. If we're going to go to point B, now we've given up 2 bicycles and we've moved and we've added 2 computers. Okay. So we take our opportunity costs. All right. 1 over, we're taking our opportunity cost. So how many bicycles did we lose? We lost 2 from 14 to 12. Okay. Then how many units did we gain? Well, we went from 0 computers to 2. So we have a 2/2 fraction, 1 bike. So the per unit opportunity cost from going to point A to point B is 1 bicycle, because that's 1 bicycle per computer added. Okay, so we're going to do the same thing going for 2, 3, and 4 from B to C, C to D, and D to E. Okay, so for the next one, we see B to C. We go from 12 to 10. Okay, so opportunity cost. We've lost 2 more bicycles. Okay, or sorry, not 12 to 10, 12 to 9. So we've lost 3 bicycles. Okay, we've added 2 more computers. So we have 3/2. So 1.5 bicycles. Okay, so on and so forth, all the way down. Okay, we see from point C to D, we go from 8 to, what would that be, 5. Okay, so 3, or sorry, 9 to 5, so 4, okay, over, and we gained 2 more computers, okay, so that would be 2, 4/2. And then the last one, D to E, we went from 5 all the way to 0 bicycles, and we went from 6/2. So 2.5 bicycles. So notice the per unit cost is increasing each time. Okay, well, why is that? Okay, that's what we call increasing opportunity cost. Okay, don't worry about this up here, but increasing opportunity costs. Okay, so anytime you produce more of one good instead of the other, because you have scarce resources, okay, you are foregoing that other resource. So the more and more we produced computers, we had to sacrifice more and more bicycles. Okay, those resources are not easily adaptable to producing both products. Um, so as we start sacrificing more and more away from one, we're losing more and more, because now we're creating more computers instead of bicycles. So we have to take, the amount of bicycles is decreasing, therefore we're increasing the opportunity cost. Okay, so the increasing opportunity cost each time we sacrifice more and more bicycles. Okay, and this results in the bowed out look of our PPC graph. Okay, all right, so we're gonna skip this. All right, so this deals with efficiency. Okay, and which types of efficiency are we using? Are we being efficient in making products, or are we not? Okay, so first type of efficiency is what we call productive efficiency. So this is producing products the least costly way or the cheapest way possible. So this is any point along the production possibilities curve. Okay, so it could be point A, it could be point D. As long as it's on the curve, that means they're producing products the most efficient way possible. Okay. Um, the other one is allocative efficiency. This is when products are being produced based on what society wants, not necessarily what is the most efficient way possible, or the quickest way, or the least costly way, because societies are all different and we all have different wants and needs. So just because it's the easiest way to produce something doesn't mean it's what society wants. So, for example, during the Soviet Union, you would see times where they would make shoes and they would produce it as efficiently as possible and make as many shoes as they could, but they made one size and one style. So you didn't have the different options for a society and what society really desire. Not everybody wants to wear, you know, boots, or not everybody wants to wear heels, or whatever it might be. So we have to produce things kind of according to society sometimes, which might not necessarily be the most efficient way possible. Okay, so productive and allocated efficiencies there. Okay, so any point, point A through D, any of these are along the line here. Okay, this is what we call the production possibilities frontier, which shows kind of the maximum efficient output out there. Okay. Um, oops. So, point or any allocative efficiencies would be anywhere inside um, any of these points because that's what society is wanting at that time. Like, society might want more computers and less bikes. Okay, it just kind of depends on what they want individually. Okay, so now we're going to get to, well, any of those what if any of these four assumptions that we already talked about, what if any of these change? Okay, we have a shift in our curve. Okay, our PPC curve. So four things that can change: resources quantity, resource quality, change in technology, or or a change in trade. Okay, any of these could be cause our curve to shift. Okay, so here's our first one. Don't worry about the numbers, don't worry about the products. Just think about if there's an increase in population. Okay, what should happen to this graph? Okay, well, if there's an increase in population, what is the new maximum efficiency that we could see from our curve? Okay, we'll just think if there's more people, there should be more workers. Therefore, we should see kind of an increase in um, overall production. Does it mean that the economy is automatically going to hit this level of production? All it means is that is the opportunity, or that's the maximum amount, the capacity that they could get to. Okay, doesn't mean they will be there, but they could get there. Okay, so that one's just a general, well, population increases. Okay, so now let's look at this one. So here's a technology change. All right, improvements in pizza ovens. Okay, so if we think about this, what's changing in this scenario? Well, it's a pizza oven, so we have more pizza ovens. Okay, so does pizza ovens changing, does that help us produce more robots? Well, no. Okay, so if we see the change, okay, we're simply going to see an increase in pizza production, but it doesn't mean we're going to see an increase in robot production. Doesn't mean they're going to produce less robots. It just means they can't produce any more than what their maximum efficiency is already. So if the max they can produce is 10, if they put 100% of their resources into robots, these pizza ovens are not going to make them produce more robots. It doesn't mean they're going to produce less robots. It just means they can't produce anymore. But they could definitely make more pizzas if technology improved. Okay, so we see that graph kind of shift to the right here for just pizza. Okay, all right. Natural disasters. So something strikes, overall, loss of production. It's going to move that maximum capacity more to the inside, and it's going to shift everything because that's going to affect pizzas and robots. Let's say, it knocks the power grid out and they have no power for a month. What's that going to do to the production? Well, it's going to drastically decrease the amount that they could actually produce. Robots cause the disaster. So we've got some Terminator action going on. Okay, well, if robots, that's going to drastically decrease the production for robots. People probably really aren't going to produce as many robots. The robots could take control. We got AI, Skynet, Terminator. Where's Arnold when we need him? Even though he's kind of the bad guy in some of those movies. Okay, but doesn't affect pizza. Okay, but it does affect robots. All right, so we got consumer goods. Okay, we don't really need to talk about that. Again, this is kind of the allocated efficiency model here. So capital goods and future growth. So like we talked about, capital goods are the things that are used to make products. Okay. Consumer goods are the products. So you see the difference here. If Panama decides they want to focus, their allocated efficiency more on consumer goods, well, future growth is not going to help them as much. They won't have the network stability, the infrastructure to grow as rapidly. Whereas Mexico, if they want to focus more on their capital goods now, yeah, consumer goods might be lacking, but future growth could be way higher. Okay, because they've built their foundation of capital goods in order to then maximize the consumer good production on the back end. So it just kind of depends, you know, where a country's going, where they want to decide, you know, what's best for them. I'm going to skip this. A couple more. New robot making technology, again, doesn't affect pizza. It's just going to shift the robots. Here's one that we have not talked about. So we're talking about demand. Now, we haven't talked about demand yet, but demand is simply wanting something and having the ability to pay for it. Okay, so think about this as society. Okay, decreasing the demand for pizzas. Does that affect how many pizzas they can make? Would it affect that? No. Now, will it affect how many they decide to make? Yes. But just because the demand for pizza is down doesn't physically mean they can no longer make as many pizzas. It just means they're choosing not to. So here's that allocative efficiency. Okay. So doesn't shift the whole curve. What we see is a point along the curve, it shifts. So here's where the society is now. Well, society moves more towards robots, but it has nothing to do with the fact that they can't produce pizzas. It just means they're choosing not to produce pizza. Okay. So anytime it's a demand shift, it just shifts the point along the curve. Okay. This could very well have said they increased their demand for pizza. So now the point wants to go here. Okay. So if you see a question that's like, put a point on the graph to show maximum efficiency or full employment of the resources, you could put the point anywhere along this line. Okay, you could put the point on pizza, you could put the point on robots, you could put it right in the middle. It doesn't matter. As long as it's on the line, that's where the country is maximizing their efficiency. Okay, their maximum capacity, whether they decide that all they want to do is make pizzas or all they want to do is make robots or they want a 50-50 split, does not matter. Okay. Okay. This is again something that just focuses on cows. No big deal. Okay. Dairy products, cheese, all kinds of stuff. All right. So any of those four things change, we have a new curve. Okay. If it's just demand, it just moves the point along the curve. And if it's talking about where is maximum efficiency, it's a point along the curve. Okay. Um, Here we go. Last one here. So many workers are unemployed. Okay, the curve does not change. Okay, unemployment just moves the point. So here's maximum efficiency. So this would be like if the natural rate of unemployment was, where it should be matching, um, maximum efficiency. So if when we enter like a recession and things like this, it doesn't mean our ability to produce is lower. It just means we're not producing there because we don't have jobs for people. Okay, so when we go through a recession, our capacity to produce products is still high, still very high. It's just the lack of workers to fill those spots, lack of money rotating around the economy to hire people, things like that. So it doesn't change what our maximum output does. It just moves the point farther to the inside. Okay, so it just kind of depends on what's going on. So if we go into a recession or something like that, definitely move the point inside the curve. Okay, so that pretty much wraps up production possibilities curves. Y'all are going to do some practice with this, shifting the curves and things like that here in just a little bit.